Good morning, students. So today we are going to discuss integration of some special forms. If you recall, so far what we have discussed? So far we have discussed the method of, transformation. Then we discussed method of substitution. Then we discussed, integration by parts. Then we discussed partial fractions. Then we discussed reduction form. And what we have learned, apart from reduction, all the other things we can use in complementary manner to achieve the solution, isn't it?
Yes.
So what we are going to discuss today is that so integration of some special forms. So if you find integration is coming in this particular forms, we can just use some steps, step by step guideline, and that will help us to find the solution. Now what does it mean? It means is that if you do not know these steps, that doesn't mean that you cannot achieve. You can always achieve by whatever the knowledge you have gained so far. But the advantage is that if you know these steps, it will help you to solve that integration problem relatively you know less time and without any hesitation. You remember yesterday we discussed about the methods of reduction,
Yes.
discussed about the advantage of reduction, and
Mm.
whenever we get advantage comes with some cost, and that cost is that I need to memorize all these formulas. Correct? No?
Yeah.
Or also the steps what we are going to discuss on specific forms, you will find that yes, it is so simple, so easy. Okay, but with a small cost that I need to remember those steps. But
Mm.
dear students, all you need to remember, not today, but over a period of a week or over a period of a month. Okay.
Mm.
Then, because we have sufficient time now. Okay. So
Mm.
the point is that, but we should remember that is the promise we should take, that yes, maybe may not be today, may not be tomorrow, but within a week or within 2 weeks or maximum within a month, I'll be absolutely clear. Correct?
Mm.
So today, what I'm going to do, today I'm going to tell about these forms. There are 11 such forms are there, and you will find it interesting. The first one, what I'm going to discuss, that is about a form. When you find an integration in this particular form. Let me show you this thing first, and then we'll discuss. With specific example, I'll explain. So here, what we saying that when you find an integration in the form of px plus q, in the numerator you will get a linear expression, and in the denominator you are getting a square root of a quadratic expression, that is ax square plus bx plus c,
Mm.
in this form, or in the other form is that px plus q, that is a linear expression, and multiplied with a square root of a quadratic expression, that is ax square plus bx plus c. If any of this form, either this form or in this form. One example, I can give you an example. Suppose you get an integration something like this: 2x plus 3 dx divided by square root of 5x square. Let me write neat and clean manner: 5x square minus 7x plus 11. Got it? No?
Yeah.
Or you get an expression something like that: integration 2x plus 3 into square root of 5x square minus 7x plus 11. Did you get my student? Did
Yes.
you get it, dear students? Okay. Then, if an integration is coming in this form, whose generic form I said,
Mm.
integration of px plus q. by square root of ax square plus bx plus c dx, which you see it here. Or you find is that px plus q, or in this form, px plus q into square root of ax square plus bx plus c dx. Then there are three steps to solve that integration. The first step is that express that numerator, that is px plus q, is equal to L into ddx of the denominator excluding the square root, that is ddx of ax square plus bx plus c plus 1 constant m. Why so? Why so? You will understand. With the moment you do it, you will get it, very simple manner, that how we can get the first integration. So there will be two integration. Now, why we are doing ddx of ax square plus bx plus c? The advantage of doing this thing is that, and what is L and M? L and M are real constant, and we need to find these values. Correct, no? So generically, what will happen? So let's take let's little deep dive into it. And how you can find the value of L and M, that I'll tell you. So suppose you get an integration something like this: px plus q divided by square root of ax square plus bx plus c dx. Correct, no? The moment you apply the first step, then what you are writing? Instead of px plus q, you write L into ddx of ax square plus bx plus c plus m by square root of x square plus bx plus c, na, dear students?
Yeah.
Dx. After that, what you will do? I'll come after some time how to find the value of L and M. It is very easy, that we can use the same concept of partial fraction. So this becomes L into, just a minute. That is equal to L into, oh, sorry. That is equal to L into integration ddx of ax square plus bx plus c divided by square root of ax square plus bx plus c dx. Correct or not? Plus m is another constant, so m we take it out. Integration dx by square root of ax square plus bx plus c. Correct?
Yeah.
Any doubt? Now let's focus on these two integrations. Okay. First integration to, it is quite simple. Can anyone give some idea how to do? Anyone, please? Gurman, Sagnik, Divanshu, Srijita, Disha, Mohot. Can you give idea that how we can solve this integration?
So the new you can take it as a variable, or
Yeah.
the numerator we can split.
So actually, if you see, um, if you make that integration, and then what you are going to get, that is actually, this particular integration, this will be what? Integration of 2ax plus b, na?
Yeah.
Divided by square root of ax square plus bx plus c dx.
Yeah.
Now you assume let ax square plus bx plus c is equal to t. Got my point, now, dear students? Are you getting my point? What I'm talking about?
Yes.
Then what will happen? That its differentiation will become as will come to the numerator. So if you make the substitution, let ax square plus bx plus c is equal to t. This implies what? 2ax plus b dx equal to dt. Correct or not?
Yes.
Anyone has any doubt, please do not hesitate to let me know. That equal to what? Integration dt divided by square root of t.
Yeah.
And I hope I no need to tell what is the how to find the integration.
Yes.
I hope it is absolutely clear to everyone, right?
Yes.
Because it is t to the power minus of
Yeah.
Gurman. Here, dear Gurman.
Yes, sir.
Yeah, integration dt by square root of t. You can do it, right?
Yes, sir.
Absolutely. All of you can do it. I know. So this is the way the first integration you can perform. Now for the second one, that also how we can express. Anyone can give any idea? I want to hear from Disha or Sagnik or Divanshu or Sijita, Gurman, whoever can. You can say how we can proceed with this integration.
Uh,
Yeah,
so
please go ahead.
consider the denominator as u, like.
That will not going to give you, after that what you'll do? You will get numerator, you will get the same thing, na?
Yeah.
Correct?
Yes.
So here, anyone, Gurman, Divanshu, Sagnik, Disha, anyone can give any idea? Okay. So the way to do this thing is that we can just, make this one square. It is integration dx by square root of integration dx by square root of. We can take a common, na? It will be x square plus b by a into ax, correct?
Okay.
Plus c by a.
Mm.
Very common practice, dear students. Please, apply this concept henceforth. So we are getting 1 by square root of a. Let me take it out. Okay. So integration dx by square root of what we will do? X square plus 2 into x into b by 2a. Correct or not?
Yeah.
Because actually it is b by a into x. To adjust this thing, I multiplied by b by 2a as 2x is there. Plus, we are introducing b by 2a whole square. Okay. Plus c by a minus b by 2a whole square. b by a whole square, not 2a, sorry, b by a whole square. Any doubt here? That is a very quite straightforward method of making the square one perfect square, right? If you recall, solving quadratic equation using completing the square,
Yes.
same approach, correct or not?
Yes.
So that is equal to what? 1 by square root of a integration dx by square root of. If you look into the first three terms, that become x plus b by a whole square, correct or not? Plus what it will be? Oh, I'm so sorry. There is a mistake I have done. B by 2a whole square. It should be 2. Correct, no?
Mm.
So what it will be? It will be 4ac minus b square, na? If you make, what you will get it here? Here you will get a square. In the denominator, it will be a square, na?
Yeah.
Not a square, actually 4a square.
Oh,
So
like
here it will be 4ac minus b square. Correct? Clear or not clear? All of you are clear? Absolutely.
Okay.
4ac minus b square, na?
Yes.
So then what we are going to get? We are going to get 1 by square root of a integration dx by square root of x plus b by 2a whole square plus square root of 4ac minus b square divided by 2a complete whole square. Looks like these are the complex expression, if you may feel, but it is actually not. It is not. It apparently it looks like so that it is a big expression, but ultimately you will get some real number value. Then this integration is in the form of integration of, you can apply the formula of integration of dx by square root of x square plus a square. Isn't it? Gurban, absolutely clear? Sagnik?
Yes, sir.
Yes, sir.
Then what is actually coming? It is in the form of Disha, absolutely clear? In the
Yes.
form of integration dx by square root of x square plus a square. Now you need to apply the formula of integration dx by square root of x square plus a square. I do not want to embarrass you by asking it. If someone can remember, you can tell me right now. Otherwise, you can look into the formula. But I just want to say you that how important that remember that formula is. Correct? Got it? So, what the steps you see? Suppose you do not know this, method. No issue, you can do it still. But remembering this method will actually make you a very procedural approach, right? Step by step manner. And you see, dear students, all my class notes, all my material in henceforth we'll discuss, especially in mathematics, a step by step procedure. What I'm getting, oh, acha, this is in this form, oh, I need to apply these concepts, these steps. So it will give you an immense confidence. Oh, I can approach this problem. And second one is that, oh, I know these steps is so well, mentioned, so I cannot do any mistakes. So now the next question is coming that how to find the value of L and M. The finding the value of L and M is very easy because it is an identity. If you look into this one, no, dear students, this is an identity. Are you getting my point? What I'm talking about?
Yeah.
This is an identity. Now, as it is an identity, you know that it is true for any value of x. So you need to apply two values of x to find it out, correct or not? So for example, if I bring it here, then what is happening to finding the value of L and M? So it becomes px plus q is equal to 2alx, correct or not? 2alx plus L into B, correct or not? Plus L into B, and ddx of L into C is 0, ddx of M is also 0 because they are in plus M. Sorry, there is a mistake I have done. Plus M. Clear or not clear? All of you are clear? Absolutely. Dear Divansu, clear, na?
Yes, sir.
Okay. Then what happened is that we can approach. First one is that what is our target? Our target is to find the value of L and M. The value of P is given to us, the value of Q is given to us, the value of A is given to us, B is given to us. For example, here, if you look into this particular question, what is the value of P? P is equal to 2. What is the value of Q? Q is equal to 3, isn't it? P is equal to 2, Q is equal to 3, A is equal to 5, B is equal to -7, and C is equal to 11. Correct or not?
Yes.
So then you can equate the like terms. Coefficient of x in the left hand side should be equal to the coefficient of x in the right hand side.
Yeah.
So that means what we are going to get, that 2al equal to p, 2 into al equal to p. So from here you find the value of L is equal to p by 2a. In fact, you can remember, you can write that one also, that L equal to p by 2a. And another thing is that LB plus M is equal to Q. So that implies M equal to Q minus LB. That is the value of M. And L value you can apply P by 2A. Correct, Anna?
Yeah.
Are you getting my point? So then ultimately you can find the value of M is equal to Q minus L is equal to P by 2A, PB by 2A. Correct or not? So you get the value of M in terms of PQAB, you get the value of L in terms of P and A. That value you can apply. I do not want you to remember that degree, that to find the value of L and M also in terms of P and Q, but you can if you wish. So if you can remember the value of L is equal to P by 2A and value of M equal to Q minus PB by 2A. Correct, na? Then what will happen? Then you can, eradicate step 2. Got my point, no?
Yes.
What is step 2? Step 2 is to determine the value of L and M by equating the coefficients of like terms of x and constant term of both sides of the equation as obtained in step 1. I just showed you how to do this thing.
Yes.
Now third step is that now the given integral is expressed as algebraic sum of two different integrals, as you see here. One integral is here. If I use this one is one integral and this is another integral. So now the given integral is expressed. The given integral is expressed as algebraic sum of two different integrals, which can be evaluated easily. How we can evaluate it easily? Because as I just showed you, correct or not?
Yeah.
First one is very easy, which is in green color,
Yes.
and second one is also easy, which is in blue color. And why we are saying it easy? Because here we can apply the previous concept. If you see, dear students, for the first one, which is in blue color, which is in green color, the first one, which is in green color, this one, here we use the method of substitution, correct or not?
Yeah.
And if you look into the right one, okay, here we use the method of transformation, isn't it? The same expression, square root of ax square plus bx plus c, we expressed as square root of x plus b by 2a whole square plus square root of 4ac minus b square by 2a whole square. Why we did so? Because we know this is in the form of dx by square root of x square plus x square, whose formula we are aware of. Correct or not? So that is why it is very important that we learn these steps. So let me make a summary before go to the next one. So how to express the integral of the form px by q by square root of ax square plus bx plus c dx, or integration of px plus q square root of ax square plus bx plus c dx. Dear students, I explained you in details about the first one, that px plus q by square root of ax square plus bx plus c. The same thing, same approach you can apply for the second one. Same approach. Okay. Then what we are going to get is that we find the value of L and M in the second step. After that, it is the simple integration of two algebraic terms. So I spent here sufficient time to explain how to do this thing. Now for the next forms, I'll just tell you the process how to do it. But before I proceed, I want to hear from everyone that you understood very clearly. Let me start with Gurman. Dear Gurman, is it absolutely clear?
Yes, sir.
No doubt, na? Achha. Sagnik?
Yes, sir.
Okay. Divyansu?
Yes, sir, it's clear.
Disha, is it absolutely clear?
Yes, sir.
Mohor?
Yes.
Okay. Srijita, absolutely clear?
Yes, sir.
Okay, great. Then, sorry, let me proceed to the next step. Next form, not next step, next form. Next form is that if we find integration of this particular form, so let me show you. I hope all of you are able to view the screen, dear students. So If you get an integration where the numerator is a quadratic expression and denominator is also a quadratic expression, or numerator is a quadratic expression and denominator is a square root of a quadratic expression. If you look into this case, ax square plus bx plus c by px square plus qx plus r dx, this form, correct? In this form, what we see, it is a numerator is a quadratic expression and denominator is a quadratic expression.
Yes.
Or if you look into the second form, ax square plus bx plus c, that is a quadratic expression, and denominator is square root of px square plus qx plus r, which is a square root of a quadratic expression. Then what to do? Then first and foremost step is that we should express that numerator quadratic expression as L into the quadratic expression as there in the denominator plus m into ddx of quadratic ddx of the denominator of the quadratic expression plus another constant n, where L, m, n are real constant to be determined. So whenever I just actually give you in a little exact execution mode, suppose you are in an exam hall, you get an integration of the form ax square plus bx plus c by px square plus qx plus r, or ax square plus bx plus c by square root of px square plus qx plus r dx. Immediately your mind should go, oh yeah, I did it with Konar sir, that numerator I should express like that, L into the denominator plus m into the ddx of the denominator, accepting the square root plus n. The moment we did this thing, then I need to find the value of LMN in the same manner. How to determine the value of LMN? By equating the coefficients of like term of ax, x square and constant term, correct? No? Of both sides of the equation as obtained in the step 1, correct? Now the given integral is expressed as algebraic sum of 3 different integrals which can be evaluated easily, correct or not?
Yeah.
Got it? Now the given integral is expressed as algebraic sum of 3 different integrals which can be evaluated easily. How it will be evaluated easily? One thing I showed you in the in the previous form, correct or not? Same thing, same approach you need to take. If you recall, dear students, yesterday when I was discussing about the method of reduction, I told you that after that class you can take couple of examples of your own and do it using the reduction formula. You will find its beauty and simplicity. Here also, after the class, you can take some example. You can take it from book. You can form your own example of quadratic expression in the numerator, denominator of the quadratic expression. Or numerator a quadratic expression, denominator is the square root of a quadratic expression, and follow these steps, you will find the solution very smoothly. If not, contact me. Getting my point? Okay, now I want to proceed to the third one, because here I'm not discussing in details because you understood, right? Exactly.
Yes.
But what is very important, you should remember which form and what steps. That's it. Now the third one is that, and these are the little challenging questions, generally important for joint entrance, and as you know, it's its advantage if you remember. Now the third form I'm going to show you. Third form is here. I'm going to show you in a new page. And here is the third form. If you get an integration where the numerator is a quadratic expression and denominator is a product of a linear expression and square root of a quadratic expression. Okay. So one example could be, if I say integration of, I can say x square plus 2x plus 11. 2 times dx doesn't make sense. Only one time is fine. That is divided by 3x. Sorry, just let me write in neat and clean manner. 3x plus 1 into square root of 4x square minus x plus 13 dx. Correct, no? If you get like this, then first step is that express the numerator quadratic expression as L into the dx plus c, which is the linear expression in the denominator, into ddx of the quadratic expression of the denominator, that is fx square plus gx plus h, plus m into the linear expression of the denominator plus n. As you know, what is lmn? Lmn are a real constant which to be determined using the second step. But first you need to remember the first step is so important that how you want to remember, how you want to express. Once you are aware of the first step, second and third step easily follows. Second step is nothing but finding the value of lmn and n by equating the coefficient of the like terms of the equation obtained in that step 1. And after that, in the third step, the given integral is expressed as an algebraic sum of 3 different integrals which can be evaluated easily. Why the word easily is there? Means this we have been done earlier. If something we have done earlier, that becomes easy for the future, right? Correct or not?
Yeah.
As we have done these things earlier, that form of integration of dx by square root of x square plus s square, or integration of differentiation of some expression divided by that expression into dx. We know how to do this thing using leveraging the standard formula and method of substitution. That is the word easily is mentioned. Fine. If there is no doubt, I can proceed for the next one, dear students. Next one, what I'm going to discuss, that is about the trigonometric functions. Okay, so trigonometric functions is of the form. Again, this is a little advanced, very unlikely to come for your board examinations, but at the same time, very important for your entrance examinations. Both are true at the same time. So the fourth form, what I'm going to discuss, dear students, here it is. If you get integration of the form p cos x plus q sin x plus r divided by a cos x plus b sin x plus c dx, or p cos x plus q sin x by a cos x plus b sin x dx. If you get in this form, what to do? Where p, q, r, a, b, c all are real numbers. Then we should express the numerator. The first step is very important always. Express the numerator as numerator equal to L into denominator plus m into ddx of the denominator plus n. Okay, I repeat. So the way we should represent numerator is equal to L into denominator plus m into ddx of denominator plus n, where L, m and n are real constant to be determined. And how we are going to determine those values? That we can find by equating the coefficient of sin x, cos x and the constant term. Correct? If you recall, in the previous cases, the 3 cases, there we discussed about the equating the like terms of x square means coefficient of x square and constant term. Here, there is no x or x square because as you see it is trigonometric function. So we should equate the coefficient of sin x, cos x and the constant term of the equation.
Okay.
Once we are achieved in step 2 that we found the value of L, M and N, then our given integration is actually expressed like something like in the step 3, that L into integration dx plus M into ddx of the denominator by denominator dx plus N into integration dx by denominator. So ddx of denominator by denominator is very easy because you will take the denominator is equal to t. That's particular, na? The ddx of denominators become dt. Correct or not? That will be done very easily. And here also you can express in the form of sine of a plus x or cos of a plus x, like that. The moment you get ax cos x plus b sin x plus c, always you can express in this form. Correct? Are you getting my point?
Yes.
Okay. So how I can tell you in brief that, how you can express in this form. So let's little bit focus on this particular part. You get a cos x plus b sin x, for example. Correct, no? Then what we'll get? What we'll do is that we divide both sides by square root of a square plus b square. Then what we'll get? We multiplied by a square plus b square. Then what we get? A by square root of a square plus b square into cos x plus b by square root of a square plus b square into sin x. Correct or not? So now we can assume that a by square root of a square plus b square is equal to sin theta. Okay. And b by square root of a square plus b square will be eventually, it will be cos theta. Correct or not? So that will be what? That will be square root of a square plus b square into sin theta into cos x plus cos theta into sin x. Correct or not?
Right.
Where sin theta is equal to a by square root of a square plus b square. Correct or not, dear students? So that will eventually make cos theta is equal to b by square root of a square plus b square. I hope I don't need to explain because we know is cos square theta plus sin square theta equal to 1.
Yes.
But then eventually what we'll get? We'll get square root of a square plus b square into sine of theta plus x. Correct, no? Sin a cos b plus cos a sin b. Then 1 by integration dx by sine theta plus x, that you can easily integrate using the knowledge what we have learned so far. Integration of cosec x dx, kind of that formula. Correct or not?
Yes.
But if you do not know these steps, if you do not know these 3 steps, that doesn't mean that you cannot do it, but you need to spend more time, as I said in the beginning of the class. Clear? If things are done, then we can proceed for the next one.
Yes.
And next one is that, it is a rational function stuff. So let me, a rational function of sin x and cos x. So what is, dear students? That integral of the form r of sin x cos x dx. That means r being a rational function of sin x and cos x. Then what is this? We'll discuss in some, in our algebra classes about these rational functions and details about it. But in this form of integrals, we will make the following substitutions based on the below mentioned case. If we find that r of minus sin x comma cos x equal to minus of r sin x comma cos x, then we substitute cos x equal to t. Okay. And if we find that r of sin means what? Instead of sin x, if we put minus sin x, and instead of cos x, we put cos x, whatever it is there. And after that, if we find the value of that rational function is minus of, apply sin x and cos x, then we should apply a substitution called cos x equal to t. Okay, that will be much more clear when we will discuss function. What you can do, you can save it for this. When you will come back to the, when you will complete our discussion on function, then again you will come back. I can give you a small example. Suppose if I say f of x comma y is equal to x square plus xy plus y square, for example. So that means, you know what, dear students? So what will be f of x comma minus y, you know? Just instead of y, I write minus y. X square plus x into minus y plus minus y whole square.
Okay.
That implies what? It becomes x square minus xy plus y square. So that same thing I mentioned, instead of here x and y, I'm getting sin theta and cos theta. Correct?
Yeah.
And the third form is that, so or here I can say, suppose I want to find f of minus x minus y. Then what will happen? It is minus x whole square, na? Plus minus x into minus y plus minus y whole square.
Yeah.
So that is equal to x square again plus xy
Plus.
plus y square, which is nothing but f of xy.
Mm.
So this particular function, we see f of minus x minus y is equal to f of xy. Similarly here, if of r of minus sin x comma cos x, which is there in case 1, is equal to minus of r sin x cos x, we will substitute cos x equal to t. For the second case, if we find r of sin x minus cos x is equal to minus of r sin x comma cos x, then we will substitute sin x equal to t. And if we find r of minus sin x minus cos x equal to r of sin x comma cos x, then we will substitute tan x equal to t. For the case 3, you can get an example something like this. Here fxy. Fxy was what? X square plus xy plus y square. But we get f of minus 6 comma minus y is just like fxy, na? Exactly similar thing. That if r of minus 6 comma minus sin x is equal to r of sin x comma cos x, then we need to make a substitution of tan x equal to t. Okay? After that, in each of these three cases, the integrals will be reduced to partial functions and can be evaluated using the method of rational fractions. Correct or not? I will tell you this particular, form as it is there in the 5.5. Okay. We can do some examples later and we'll understand exactly how it has been done. And that will be good to do once we complete our discussion on functions. So now let me go to the next step. That is the next form. Okay. The next form is a form of, sin to the power mx into cos to the power nx dx. So as you see, dear students, that if you get an integration in the form of sin to the power mx into cos to the power nx dx, in this form of integrals, we will make the following substitution based on the below mentioned cases. The first one, case 1, when both m and n are natural numbers. when m and n both are natural numbers, what you are going to do? If both m and n is odd, then substitute for terms of even power. Got it? Are you getting my point? They substitute for terms of even power. Okay? Means if one of m and n is odd, suppose m is odd, n is even, then we need to substitute for the terms of the even power. That means if cos x equal to t, we need to. Got it? If both m and n are odd, second subcase of case 1, then substitute either of them. No issue. You can take either sin x or cos x.
Okay.
If both m and n are even, use the formula of trigonometric identities only to simplify it. Suppose you get sin square x into cos square x dx. That means sin x into cos x whole square. Then you can make 2 sin x cos x and adjust by dividing by 2. 2 sin x cos x means what? Sin 2x. And sin 2x again you can apply in the formula of sin 2x whole square. You can apply the formula using that, trigonometric identities. Correct or not?
Yes.
So that you need to do. You can take some examples and do it once the class is done. Now the second case, the first case we are done with. In the second case, if both m and n are rational numbers. Rational number, the number which can be expressed in the form of p by q, where q is not equal to 0 and HCF of p and q is equal to 1. Then we will find the value of m plus n minus 2 by 2. If it is a negative integer, then substitute cot x equal to p or tan x equal to p as found suitable. You can take tan x equal to p also. So this is the step for the 5.6. Now let me go to the next one. Okay. The next one, what I'm going to say is that this particular 5.7, that it will be more meaningful once we are completing the discussion of function and again come back. But for the sake of completeness, I am informing it now so that later when you come back to this particular note, you will understand, this has been done and I can approach this method. Now I understood functions later. So what is that? If you get an integration, of the form f of x and ax plus b power 1 by n dx, means it is a function of two variables. One variable is x, the other variable is ax plus b power 1 by n. If you get in this form, then your first and foremost things should be to make the substitution ax plus b is equal to t power n. Okay? And due to this substitution, you will find the given integration is actually transformed to this one. After that, you will find you are able to proceed it very easily. Okay? I will tell you that, this particular case and earlier case also, you can wait for some time till we discuss the function. Correct? No? But I'm telling all these things why? Because these are going to be, you will never find an indefinite integration question, dear students, okay, which we have not discussed so far. Indefinite integration is one among the few, topics in mathematics where there are varieties of questions. Now, when there are varieties of questions, okay, the best thing is to find the pattern. Because if you can classify from that variety a particular pattern, you can actually, concentrate more and you have already isolated. After that, you are applying your knowledge. That's why I mentioned this step-by-step manner. The next one, you can do it right now. You don't need to wait for any other class. And I'm going to show it right now. Means any other class related to function I'm talking about. So you can do it right now, and very, very important form of integration. And you definitely you need to remember this thing very, very well. Okay, what is that? If you, let me put it first. If you find integration of dx by a linear expression x minus k into square root of a quadratic expression like ax square plus bx plus c, as you see it here, then your first step should be make the substitution x minus k is equal to 1 by t. Now, if you make that substitution, you will find the given integration is actually transformed to this form: integration dt by square root of capital A t square, capital B t plus capital C, where capital A, capital B, capital C is other real values you can compute based on this substitution. Once you get this thing, after that you can make that completing the square, na? Remember, we did one. Okay, completing the square, and then you can apply the formula of integration of square root of dx by square root of x square plus a square formula.
Yes.
Correct? And you can proceed accordingly. This is a very important form that you should be knowing. You should apply this concept. In fact, you can do one problem once the class is done, and you can let me know how things are going on. The next form, what I'm going to tell, that is also very important. Okay, little complex form. Okay, but important for mainly for joint entrance examinations. And here it is. The form, if you get an integration of this one, that integration of dx by x minus k power r, that means what is power r? That is a linear expression. That is x minus k, that is a linear expression. On top of power r, though ultimately it becomes a polynomial expression of degree r, into square root of ax square plus bx plus c. If you get in this form, your first step should be make the substitution x minus k is equal to 1 by t. And then due to this substitution, what we will get? We'll get the entire integration is transformed to something like this. And this form can be integrated very easily. How? Just take an example and proceed. You will find again, easily means what? Easily means if we have done something earlier of similar problem, that becomes now the present problem become easy. So that's what we will do. This form. So the last two forms I have left with, okay, and that I'm going to discuss. So these two forms are also, quite important for entrance examination, and these are not at all important for board examination at the same time. In board examinations, this will not come. Here, in this form, dear students, if you get an integration where numerator is only dx, denominator is a quadratic expression into square root of a quadratic expression. Okay, that is like integration dx by ax square plus b by square root of cx square plus d. Then we should make a substitution x is equal to 1 by t. And due to this substitution, that x equal to 1 by t, our given integration will be transformed something like this. After that, what you will do? After that, you will make another substitution like c plus capital dt square equal to u square. And due to this substitution, the integrand what we get in the form 2 transformed 1 will again get transformed to a form like integration du by either u square plus a square or u square minus a square, which you can integrate very easily because you know the formula of integration dx by x square plus a square or integration dx by x square minus a square.
Yeah.
So in this particular case, dear students, there are 2 times substitution is happening. The first substitution is that x equal to 1 by t, which is there in the step 1. After that, you get this form as you see in the step 2. And after that, whatever you get in the step 2, that integration of t dt by capital A plus capital B t square into square root of C plus capital dt square. Again, we make another substitution is as like C plus capital dt square equal to u square. And then you get a new transformed one, which is integration of du by u square plus minus a square. You will get either plus a square or minus a square. But in any case, you know the formula and proceed further, right? No, dear students?
Yes.
So the last form, and that is the final one, after that no other forms, is that this is quite advanced one. So let me first, provide this one that, relevant, steps, and then we'll discuss. If you get integration of the form x to the power m into a plus bx power n whole power p dx, very advanced form of integration. I repeat, only important for joint entrance. There are 3 different cases to occur in this form of integral. Following are the cases and the respective method to solve this integral. The case 1, if p, that what is that, ax plus b, sorry, a plus b x power n power p, na, that p. If p belongs to the set of natural numbers, our process is that expand the integral with the help of binomial theorem and then integrate. We'll discuss later when you complete discussing binomial theorem. Case 2 is that if p belongs to I, the set of integers, then we should make a substitution of x equal to p power k, where k is the LCM of m and n. Case 3 is that when m plus 1 by n is an integer. So how we will proceed, dear students? First case 1. If case 1 is not done, then come to case 2. It doesn't come into the case 2, then come to case 3. That when m plus 1 by n is an integer, then we'll make a substitution of a plus b into x power n is equal to r power k, where k is the denominator of the fraction p.
Yes.
Okay. Then the fourth case is that when m plus 1 by n plus p is an integer, if it is so, then you make a substitution a plus b into x power n is equal to r power k into x power n, where k is the denominator of the fraction p. Okay. In each of these above mentioned cases, the integral will be reduced to a form which you are comfortable to integrate. Correct, no? So first you need to try for case 1. If it is not fall into the category of case 1, come to case 2. If it is not fall into the category of case 2, come to case 3. If it is not fall into the category of case 3, come to case 4 and proceed. I will suggest, dear students, please do this thing that, last 3-4, forms, once you are done with, well versed with indefinite integration. With this, I would like to conclude the class for today, unless you have any specific comments. As I said in the beginning of the class, for the 10 questions of differential and integral calculus, I will be in touch with each one of you. And that's all about today's class, dear students. And our next class is day after tomorrow. And there we will start discussing definite integration. Okay.
Oh,
Thank you very much. Take care. We'll
yes.
see you day after tomorrow at 9:30 a.m. Okay.
Yes.
Thanks.